Okay, so good day everyone. Welcome back to my channel. I am your teacher Marielle, and for today's tutorial video, we will talk or discuss about the conic sections. So conic sections has a curve, circle, parabola, ellipse, and hyperbola. So during the classical Greek period around 600 to 300 BC, conic sections were discovered. Apollonius 262 to 190 BC produces an 8-volume work at the beginning of the Alexandrian period. Conic section is a curve formed when a plane intersects a right circular cone or double knot cone. These resulting the curves are hyperbola, circle, ellipse, and the parabola. So the general second degree form of a conic section is ax squared plus byx plus cy squared plus dx plus ey plus f is equal to 0. It has a discriminant of b squared minus 4ac, which can be utilized in determining the type of conic section. So using this formula, we can determine the type of conic section. So here, we can determine the type of conic section based on the discriminant. So if our discriminant the discriminant is equal to 0, so that is parabola. And if it is greater than 0, so that is hyperbola. And if our discriminant is less than 0, whether it is ellipse or a circle, but you can determine if it is ellipse if the b is not unequal to 0 or the c or a is not unequal to c. So you can determine also if it is a circle if b is equal to 0 and a is equal to c. So say for example, identify what type of conic is given 2x squared plus y squared plus 4x is equal to 0. So first, we can determine the value of our a, b, and c based on the general second degree form of a conic section, which is ax squared plus byx plus cy squared plus dx plus ey plus f is equals to 0. So since our a is belong to the coefficient of x squared, so the value of our a will be 2. Then b will be 0 since there is no combined y and x. Then our c will be 1 since the coefficient is belong to y squared. We see that c is the coefficient of y squared, so c will be 1. And then we can now substitute this value to our formula, which is b squared minus 4ac. So the value of our b is 0, so this will be 0 squared minus 4. The value of our a is 2 and the value of our c is 1, so 2 times 1 is 2. So this will be 0 squared minus 4 times 2 and 0 minus 8. So since our discriminant is negative 8 and 0, so discriminant is less than 0, and we can see that our a is not unequal to c, so this is an ellipse. Identify the conic given by 9x squared minus 4y squared minus 18x plus 16y minus 43 is equal to 0. So the general form of the conic section is ax squared plus byx plus cy squared plus dx plus ey plus f is equal to 0. So the value of our a here is 9, since this is the coefficient of our x squared, no? Ax squared. So a will be the coefficient, and in our given, 9 will be the coefficient of x squared. So a will be 9. Next is the value of our b is 0 since there is no x and y, no, in b, y and x. And our c is -4 since this is the coefficient of y squared, cy squared. So our cy squared here is -4y squared. So the coefficient is -4. So the value of our c is -4. Next, we can substitute this value to our formula, which is the value of RB is 0 squared, 0. So this will be 0 squared minus 4. The value of RA is 9. The value of RC is -4. So 0 squared is 0. And 4 times 9 times -4 is, this is positive 144. Positive 144. So since our discriminant is greater than 0, so this is hyperbola. Next we have x squared minus 4 or y squared minus 1 is equal to 0. So first we need to identify the value of our a, b, and c. So a, we can find the a and x squared. So since our there is no coefficient, so automatic 1 na lang siya. So the value of RA will be 1, the value of RB is 0, also 0, and the value of RC is -1 since it belongs to y squared, the coefficient of y squared. So next we can substitute this value to our formula. So our b is 0, so 0 squared minus 4 times the value of RA is 1, the value of RC is -1. So 0 squared is 0 minus 4 times 1 times -4 times 1 is 0 plus 4. So since our discriminant is greater than 0, so this is also hyperbola. So I think you are ready to answer or determine what type of conic section. You can base on the discriminant of the conic section to determine what type of conic section is this. So you can comment down your answer, and thank you for listening.